Welcome, everyone. It's my pleasure today to introduce this presentation on an innovative, non-volatile memory for medical devices sterilized using gamma irradiation. This presentation came about today because of a collaboration between two very different companies but with a common goal, Nordion and Adesto Technologies. My name is Emily Craven. I'm the Manager of Sterilization and Science and Engineering at Nordion. And before I hand this presentation over to Bor, I wanted to provide some background as to how this alliance came about. Nordion is a specialty healthcare company whose main product is nuclear isotopes used in medical and industrial applications. Our cobalt-60 is used in gamma irradiation systems which are used to sterilize medical devices. We also provide the irradiators that this cobalt is used in. The Gamma Center of Excellence is Nordion's applied research and specialty gamma processing facility with the mission to expand and enhance the use of gamma through outreach and education. The GCE provides contract irradiation service, but has dedicated irradiation time and resources to research and development projects and collaborations with companies like Adesto who want to explore gamma applications. As a company whose main product is the source of radiation and not the irradiation service, Nordion recognizes that our business will only be successful if our customers' businesses are successful, and our business will only grow if more products are gamma sterilized. This is why we've made our resources available to test out new ideas and applications for gamma irradiation. Because of the nature of our facility, we can offer specialized irradiations at any scale. The GCE has a full-size production irradiator which can be shut down and emptied out to do very large-scale yet precise irradiations. We also have a smaller underwater system, which is used day in and day out for sample irradiations. And for small yet highly accurate doses, we have a calibrated source, complete with an environmental chamber that can produce a temperature range down to minus 100 degrees Celsius. As the company which has designed and installed most of the large-scale gamma irradiation facilities in the world today, we have developed and validated specialized modeling tools over the years, which can help us to design experiments either at our facilities or at our customers' facilities to provide extremely uniform doses. We also run a dosimetry lab, which is recognized through the NIST Voluntary Laboratory Accreditation Program, which means that we have the ability to accurately measure the doses that we deliver, and we can also provide calibration services to our customers. Through the Sterilization Science Program at the GCE, we have participated in a number of collaborations to promote the use of gamma technology. We specifically seek out collaborations which will enhance the use of gamma for high-value devices, expand the use of gamma to new industries, and which allow us and others to research gamma effects on new and unique materials. We've had a range of collaboration partners so far, including medical device manufacturers, polymer manufacturers, universities, research institutions, laboratories, and more. When we first heard about Adesto, we honestly didn't know what to expect because generally speaking, electronics and radiation don't mix. But after speaking with Bor and other members of the Adesto team, we realized that we were talking about a unique new technology that had the potential to be compatible with gamma sterilization and open up the medical device world to a whole new set of applications. So we actually jumped at the chance to work together. So today, I'm very happy to introduce Adesto and Bor Peterson, who will talk about the results of our collaboration together. Bor.
Thank you. Good afternoon. My name is Bor Peterson. I'm the Senior Manager of Technical Marketing for Adesto Technologies. And the important problem we're trying to solve here today is how to get more electronic devices into products that have to be sterilized. The market is growing significantly over the next couple of years, and anything that goes into the medical field have to be sterilized one way or another. And the big problem for electronics is that existing memory devices really cannot handle many of the sterilization methods in use. Adesto introduced CBRAM, which is the new solution that will enable electronic devices to be fully compatible with all sterilization methods, even the more harsh ones like gamma radiation. Memory is the backbone of all intelligence devices. You have the brains being the CPU, the processor, and the processor needs program storage to be able to execute. You need to log data, you need to store data. You also need to store reference values for controller operations. If your application uses RFID, you need to store unique numbers and trace data. And then, of course, you have all the cases where you need to enter user information into the device itself. Regular semiconductor memory is based on storing electrons in an insulated region of the device. You have a certain number of electrons, it counts as a logical 1, otherwise it counts as a logical 0. Lots of zeros and ones together make up all the data you're storing. If you try to radiate a device like that, the electrons will escape and your data will be erased or scrambled. And the big problem is that you're not only erasing your program that you stored into the device, which you in worst case could reprogram after sterilization, you'll also be erasing any factory settings that the semiconductor manufacturer put into the device, which means you didn't only erase the device, you broke it. You also have to have sterilization where you use heat or pressure for re-sterilization in autoclave. And our system is the only available system that can handle both gamma radiation and high temperature. Standard EEPROM and flash technology can handle the temperature, but cannot handle the gamma radiation. So a lot of medical devices today are either built without any kind of electronic devices inside, even though the supplier would love to have them in there, or it becomes a two-step process where the electronics and the rest of the systems are treated separately and then have to be merged together after sterilization and then packaged, which means it's a much more inconvenient process for packaging and shipping than if you could just package everything up front, run it through the sterilization chamber, and be done. This increases the cost of the system, it increases logistics, it makes everything more difficult than if you had memory you could just sterilize. So with Adesto CBRAM, you get a technology that is both low power, fast, and robust. We have tested devices to pass 5 megarads of gamma radiation. We also have devices that have been sitting in the hot oven for the last 9 months. My colleague over here has been testing them every now and then to see if they're still surviving. And after 9 months at 200 degrees C, we still haven't seen any change of data. These devices also operate on much lower power levels than regular flash devices. We can typically have a write and read voltage as low as 1 volt, while flash devices typically need on-chip voltages above 12 volts for programming. This means that the total energy consumption of the devices becomes much lower. You may be able to operate without batteries, just use energy harvesting for powering your systems. So you either get much longer battery life or you work without batteries altogether. At the same time, the devices are very fast. You have the same read time as you have on other memory types, but you also have the same write time, where flash memory devices have a write time that is much longer than the read time. This is very important when you have a limited amount of energy available for your storage. You have much less energy required for writing the amount of data, which means you can write faster, you can harvest less energy. If this is part of an RF system where you're powered from the RF field itself, like with RFID, you get longer range and less power consumption, which means you need a smaller RF circuit. We did a couple of gamma ray studies, we put a couple of flash devices in as well, just for reference. And these, even at the lowest doses we tested, came back with failing bits. Putting the CBRAM devices to the same setup, we got no errors whatsoever. And that's when we got in touch with Nordion to get some real gamma testing done. And we went all the way up to 5 megarads, which is twice the normal dose used for sterilization. And we still came out with no failing bits. So we're going to continue this test and see how high is high and how high we can go before the devices finally fail, in case people want this for systems where they may need to re-sterilize once or twice because the first setup has to be changed. Data storage for medical devices. The low power of the CBRAM means it's very well used for anything that is battery-operated wearable techniques. It can be ultra-low power embedded. You use energy harvesting and you have no battery or cord whatsoever. Gas flow sensors, fluid management, orthopedics, and of course, with the high temperature capability, we can also handle surgical multi-use sterilization, where things may be gamma ray sterilized for first time use and then re-sterilized on a daily basis in autoclave. We see a big potential market in RFID applications, where RFID is used for tracking of sterilized devices. Just think about it. Whenever you go to a doctor's office today, the first thing they do is to print out about 20 barcode labels and put them on various test tubes. And that means that all those labels have to be read manually by someone down the line. So there's an enormous amount of time being spent in the healthcare industry with someone holding a barcode scanner and rereading the same information again and again and again. If you had RFID already embedded in the test tube, you could have the reader doing all that automatically, and you save an enormous amount of manual labor in the process. Same thing goes for things like smart syringes, any kind of medical container, sample containers. By embedded the memory and the RFID in the devices, you reduce manual operations to a minimum. Another great advantage of the CBRAM is due to the fact that with ultra-low energy, it can be used for a lot of body sensing applications, where you just harvest energy from the environment. And if you want to, let's say, do a week-long study of a patient and have them hooked up to an ECG machine, you get a lot of wires around, and it's really inconvenient for people to walk around with wires connected to them all the time. If you use these sensors wireless and you harvest energy or have small batteries, you store all the data and you transfer it, for instance, to your cell phone at a convenient time. That way, the patient can move around and do everything they do on a daily basis, and you collect all the data on the fly without having to have the patient hooked up to a central system all the time. Quick introduction to Adesto as a company. We are a memory company, have more than 100 employees. More than half are in research and development. We do both CBRAM memory, which is what we're talking about here, but also traditional flash memories, and we've been doing that in volume production for many years. We're a worldwide company. We have customers all over the planet using our devices. I've seen them in many applications on the floor here today. We serve consumer markets, we serve the medical market, industrial, mobile markets, Internet of Things, security. We are everywhere in the memory industry. What we see as growth markets is anywhere where you find electronics, handheld devices. The new great thing we believe everyone will be wearing in a couple of years will be all these smart watches. PC industry, home appliances, automotive, smart cards. And our customer base are all of the usual suspects. We support these with the Data Flash family, which is mainly for data storage. We have a low power Fusion family for energy harvesting applications and low power devices. We have the BIOS Flash, which is more a standard boot memory type. And now the CBRAM, which can cover all of the above. The CBRAM, we think, will be a preferred memory technology going forward for a lot of applications. And as we've seen today, particularly for medical applications, because it can be sterilized with any kind of available technology. So for more information, you can contact me or Mr. Paul Fullhorst, who is sitting in the back here. We have a case study for gamma radiation tolerant CBRAM technology. And for all our other products, they're also available on our website.